Hello everybody, this is Mr. Bowman. So today we're going to be looking at our next transformation, which is known as a reflection, okay? Or is sometimes known as a flip. Okay, a little high there. So what this does is we're going to take a line and flip either a point or maybe a polygon again, and we're going to flip it on the other side or reflect it over. So usually when we start these, we start with flipping things over the axes because they're the easiest lines to see. Okay. So if I take say a point here and I want to reflect it over the y-axis, what I'm going to do is I'm going to figure out how far that point is away from my y-axis. So in this case, it is 3 away. And I'm going to move, let's call this A, by the way. And I'm going to move another 3 this way, and that's where my A prime is. So it's going to be the same distance as the original one, but on the other side. Okay, so that's 3 away over here, so its reflection would be 3 away here. Or, likewise, I could flip it over the x-axis, right? Which in this case is not 3 away, but 4. So I'm going to go another 4, and this I'll call this a double prime since I already have an A prime. So it's all about replicating that distance on the other side of your line. Now, sometimes you may not be reflecting over the axis, but it works very similarly. So if I have a point here, well, let's call this one B, and say I want to flip it over this vertical line instead of my y-axis. Okay, so I'm going to flip this over the line x equals 2. It's the same process, but I'm not counting how far I am away from the axis anymore. I'm counting how far away we are from my line, which is known as the axis of symmetry. Okay, so I am 2 away from my axis of symmetry, so I'm going to go another 2 over here, and that's where my B prime would be located. And that works the same way regardless of whether it's a vertical or horizontal line. Doesn't make a big difference. So, very similarly to when we did our polygons with translations, when we do our polygons with reflections, it's still just taking those vertices and flipping them around. Okay. So, let's do a triangle here. Making sure I have this labeled, so we'll call it A, B, and C, pretty classic. And I'm going to flip it over the x-axis here. So the x-axis is going to be my axis of symmetry. So I want to figure out each point, how far it is away, and then go the same distance on the other side. So my A right now is 3 away, 1, 2, 3. So I'm going to go another 1, 2, 3 here and put A prime. Similarly with C, it's 3 away, so C prime. B is 1, 2, 3, 4, 5, 6 away. So 1, 2, 3, 4, 5, 6 away here. And I get that shape. Now hopefully you can see why this cannot be replicated with translations, because as I'm looking at this, if I have a translation, it's going to keep the same orientation and just move around. This is reversed. Instead of the B being the highest point, it's now the lowest point. So there's no way to translate this and land here. It has to actually change its orientation. It's harder to see that with a point, because a point can be replicated because it has no orientation. So it looks like reflecting this would be the same as, say, translating it 6 to the right. But when you get those polygons, you can start to see why they're different. Okay. All right, so let's do one more with a polygon. Let's say I have a square here. And the actual shape doesn't matter all that much. We just really care about how many vertices it has. And I'm going to flip this one over the line x equals 6. Okay, so we're going to flip it over here. And we may fall off our graph a little bit. That's okay. I didn't measure that very well. So this one is currently 1, 2, 3, 4, 5 away. So 1, 2, 3, oh, none of them are going to land on the graph. Okay, well, then let's pick a different line. Scratch that. Let's go ahead and we'll flip this vertically, maybe. Apologies. So let's flip this over y equals 1. So that'd be right here. We should have plenty of room this time. So our D is 2 away from my line of symmetry, so I'm going to go 2 down and make this D prime. C is 2 away, so I'm going to go to my line of symmetry and go 2 down, C prime. A is 1, 2, 3, 4, 5 away, so line of symmetry, 1, 2, 3, 4, 5. And then B is 5 away, so 1, 2, 3, 4, 5, B. Remember, you're always coming back and counting or measuring from your line of symmetry, not, say, an axis. That's the part where a lot of people make a mistake when they're doing this, is they want to count from the axis out of habit, like the x or y axis, not the axis of symmetry, which is the new axis that I care about. So it takes a little getting used to, but that's how reflections work.